Problem 3. Still dealing with line dilations. This time it's centered at a point other than the origin. And remember, this is a Regents culminating course, so at the end of the year you're going to be taking the Regents, and these exams are scripted. If they don't say about the origin, it's 99% of the time going to be a point on the line. But we should do our due diligence and check. So when we do a dilation about a point on the line, the key thing to remember is that the equation of the image does not change. It's the same as whatever the equation of the original is, which they give us. So this problem really comes down to, is this point 4, 2 on our line? Is this x value and this y value, are they on our line? Do they belong to the equation of that line? So we can check by substituting. I can just be like, it's 9 times whatever our x value is, which is 4. That's supposed to get subtracted by 3 times whatever our y value is, which is 2. And that apparently needs to equal 30. I'll clean this up a little bit. So if we follow the order of operations, 9 times 4 is 36. Negative 3 times 2 is minus 6, and that supposedly equals 30. And 36 take away 6 is 30, and 30 does in fact equal 30. This is how we know the point is on our line. So this equation is literally our answer. I could write 9x minus 3y equals 30, and I could be done. Or I could go one step further and solve for y. All right, so we'll do that. Got y there. So I'm trying to solve for y. I got to get rid of that x term first. Whatever I do to one side, do the other. Drop down that minus 3y. 30 minus 9x. Well, I got to get rid of that minus 3, so I got to divide because it's attached by multiplication. Whatever I do to one side, do to all the terms on my other side. And I'll get y equals, and then the result of 30 divided by minus 3 is minus 10. And these negatives here are going to cancel out, and I'll get a positive. And now my slope is 9/3, or 9 divided by 3, or in other words, 3. And there's the x term. So if I rewrite that in slope-intercept, you're going to have 3 as a slope, because it's attached to x. And then that minus 10 is your y-intercept. So that would be our final answer, either the equation they give us, y equals 3x minus 10, because the equation doesn't change when we do a dilation about a point on the line. If you like that and you buy it, good. If you are curious to see that it really is the same equation, keep on watching. And if you kind of want to see why it works, this would be a good example. I think I have a good visual for it. So we're going to just type in the line they give us, 9x minus 3y equals 30. So we got 9x minus 3y equals 30. Boom. There's our line. I'll put it in y equals 3x minus 10. Yep, that's what we had there. So I'll pop back up. And we were supposedly dilating about the point 4, 2 right there. So I'll graph that as well. I'll put that in coordinates. 4, 2. And that point is going to be on the line, and you can see it right there. It is on the line. So why this works, let's take a look. I'm going to plot another point right there, and sure, I'll color it red, and there's our point of dilation. Well, the reason why when we, and I'll even prove it to you, when we take this line and we dilate it about that 4, 2, whatever the scale factor is, it really doesn't matter. They said 7/2, sure. 7/2. The line stays exactly where it is. It stays put. And that's because, well, think about how a dilation works. Dilations are going to use the slope from the center of dilation, which is point A, which also happens to be on our line. But it's going to do the rise, which is 3, and the run to another point. That's on the thing we're dilating. And then it's just going to keep on repeating that, however many times your dilation is. But the thing is, our center of dilation is a point on the line. So that slope dilation that we're using to make the dilation, it's literally the same thing as the slope of the line. And the things we're dilating, the thing we're dilating, B, and the thing we're dilating about, it's just points on the line. So doing the dilation about point A for any point on this line, it's the same thing as just picking 2 points on the line and doing the slope. You're just going to keep on repeatedly getting points. If I keep on doing that slope of rise 3, run 1, I'm just going to keep on getting points on my line. Well, if I can actually click. Right? It's never going to change. It doesn't matter how many times I do this. Like, it's the same line. And that's because the slope of the dilation is the same as the slope of the line. And we're dilating points that are on that line. So that's hopefully a better explanation and a nice visual to go along with it.